This is John Sarver, and welcome to My Solar Story, sponsored by GLREA and the Michigan Solar Users Network. Tonight, John Dohner is going to talk to us about his solar system and his geothermal system. We've had a lot of interest in this kind of topic in some previous sessions, and so John has volunteered to kind of talk about his own system, and I think we'll have an interesting discussion. So please mute yourself until we get to the question and answer period. And you may notice my screen is, at least it looks like, a little screwed up for at least where I'm seeing it. But hey, well, John, go ahead.
Thank you, John. So we're located in Lima Township, Washtenaw County. That's about 10 miles west of Ann Arbor and about 1 mile north of I-94. We're on about 10 acres, raise sheep, and do a little beekeeping. And we happen to have a barn that is 28 feet wide and 80 feet long with a south-facing roof. And we've always felt that it was an excellent opportunity to utilize that roof for something more than just keeping the rain off. So that's what we've done. We decided that we wanted to use that roof that was perfectly located with no basic shade, with no shading, that was south-facing. Hey, John, hang on just a second. I got a note that my iPad is low. So it always happens at the worst possible time, doesn't it? So let me plug it in. Okay. Let me turn the thing down on this. Okay. So we basically decided to execute a project a couple of years ago. The goals were pretty basic. We really wanted it to be a green project. We wanted to do it for, the benefit of just getting our carbon load down and all of those positive things that people talk about. We also wanted to get payback within about a 10-year period of time. If it was a little more, a little less, that wasn't important, but the target was around 10 years. And we wanted a phased implementation because, there are so many things that are changing all the time. We wanted to do this in pieces rather than all at one time. So some of the challenges were, we got a lot of quotes from a lot of different people. They range from, oh, you need 13 kilowatts to, you need 4 kilowatts. We had some physical challenges. The barn, as you noticed on that original slide, is a long way away from the house. It's actually 200 feet from the main breaker out to that roof. And we have 3 meters on the house. We have one for geothermal, one for hot water, and one for the whole house, and they all have different rates. And there were a lot of unknowns, this constant changing in the battery technology, and maybe we can talk about that a little bit later. And then just dealing with DTE and this whole issue of net metering versus this Rider 18 approach. Unfortunately, we didn't get our project together in order to get onto net metering. I didn't think that was going to be as big of a problem, and just in terms of payback, as it obviously is. There's a huge difference between those two approaches in terms of payback. But project definition, we decided to go with a company called Go Green Solar, and we decided to do much of it ourselves. They basically designed, configured, bought, shipped all of the stuff. They put it on a pallet, they send it to us, and then they had a kind of a line item in the project for a standard set of consultation. I got to tell you, this was by far the most economical way of going about getting this implemented. The project ended up being about 4.13 kilowatts. We ended up going with 14 in-phase IQ7 inverters, which the inverters are about 297 watts. And then the PV is the Hanwei Q cells, which are 390 watts. And if we get a chance, we can talk about why there's a mismatch between those two and what the ramifications are. I didn't really realize when they bought it, they configured, they engineered it, they did it this way. I didn't really realize that until April when this thing started clipping during cloud-free days. And there were some physical challenges, as I mentioned. The barn is about 200 feet away from that main box. We also decided that since we're going to put that power out to the barn, which was kind of a desirable thing anyway, we'd also put an intermediate location, a sub panel in the garage to accommodate a future EV, which is something that is in our plans to do as soon as the vehicles are available to go 250 miles without a charge and reasonably priced. So the panel locations ended up on the roof. They ended up fairly centered up on the top. This picture was taken in late October, early November. Actually, I think it was almost exactly this time last year. You can see there's a big tree that is shading that run-in area, but it really doesn't affect the panels except for about a few weeks in December and into a few weeks in January. But quite frankly, we don't get a lot of solar during that time anyway. That's also a tree that loses its leaves. So it really, in a week or two, it'll only be shadowed by some branches. So one of the things that these guys did as a consultation part of their effort is they gave us some really detailed instructions on how to put this together. And one of the things that they did is they told us and gave us some ideas and a kind of a point-by-point instructions on how to lay out those photocells as well as how to do the wiring. And since they bought every piece, every bolt, every nut, every rail, they had all packaged up. When it arrived, everything was available. We took it apart, we laid it out, checked it against the bill of material, and basically went to work. One of the interesting things is this has gone up on a metal roof. I had some really concerns about doing that, but after installing it, this went in like a dream. I mean, this was not. Once it was laid out, it really went up and went together very fast. By the way, this whole physical installation only took one day. The crew over here is the woman on the left is my daughter, the man on the right is my son, and the guy in between is my daughter's husband. We had a little bit of an advantage in that I'm an engineer, my son's an engineer, my daughter works for a construction company, and my son-in-law is very familiar with construction and related activities. Has done them a long time. So you can see all of those connectors went in, all of the rails go on. It was really pretty straightforward. If you notice those connectors, they adjust. We ran a line along it. Inside of about 3 hours, those rails were in place and ready to go. Since we used in-phase, that's a distributed inverters. So every panel is going to end up with an inverter. They went on really fast. They connected together really quick. It's really plug and play. They all just plugged together. It was the hardest. The thing that took the longest was putting the conduit between the combiner box and the panels. Everything else went in with a lot of ease. The only thing that I think we really needed to have some muscle on, I'm thinking almost anybody could have done the part up to this part, was actually physically picking up those big panels, getting them up on the roof, moving them into place, and putting them down. That did take some muscle. I'm sure other people could do it, but I'd hate to have dropped one of those. And as you can see, by the middle of the afternoon, they're pretty much in place and ready to go and ready to wire. One of the things I liked about this installation is everything is under the panel, so nothing is really exposed to the snow and to rain and to the climate. It's a very, very clean installation. It looked very clean. On the other hand, the panel is physically, and everything is physically off of the metal roof. It's very accessible. If we have to go back in and do change out an inverter, you can see that the inverter is physically right there at the top. I do think that, although I'm not sure you'd have to, but I suspect you'll have to unclamp the two clamps on the side of the panel, lift it up a little bit so you can get your hands in and unplug the microinverter. We've had this for a year. It's been installed. We've had absolutely zero trouble with anything. Everything has been very balanced. Everything has functioned really perfectly. There's two arrays that you saw up there. I divided them into two. I probably could have put them on one, but just in the interest of distributing the load, we put it into two arrays. Enphase has what they call a combiner box. The combiner box will accept up to 3 arrays. It has the electronics to do the measurement of the current that's being produced, and a Wi-Fi capability to communicate with the internet and the network. In our case, we use two of the breakers, 2 of the arrays. There's room for a 3rd array, and that, for me, that was important because these are IQ7s. Their later product is called the IQ8. The IQ8 is going to have us provide some functionality and capability to function on a mini grid. And that was important for us as a future phase, because one of the things that we wanted to do is we wanted to be able to use this as a system that would work standalone, where if we do disconnect from the grid, from the Detroit Edison grid, that we could establish a mini grid and we could go on utilizing these arrays, et cetera. The IQ7 does not have that capability. If we are, it's grid tied. So once we lose the grid, the panels go down. It is going to be possible when the IQ8s are available. Hopefully we'll be able to plug them in on that 3rd array, and we'll utilize those to be able to establish the mini grid and allow everything to function when it's isolated from Detroit Edison's grid. There's also a location on here for a battery system. And I'm not sure, I was never really even considered that. Batteries are important to us, but we want them to be relatively smart batteries. We want them to be able to handle some functions that basically an out-of-the-box batteries system probably wouldn't handle. We can talk about that again when we look at some of the software and why I say that. So if you look at our meters, we actually have 3 meters. One's for the geothermal, which is a time of day rate. So there's really 4 rates associated with that meter. There's the summer, peak, off peak, and then there's the winter, peak and off peak, and they can be very different. There is the hot water interruptible meter. And then the center one is the whole house, and that's the one that we have our geothermal, or I'm sorry, our solar hooked to. On the far right, you can see the cutoff switch that Detroit Edison insists on having. You know, personally, I think the only reason why they want that cutoff switch is when the Detroit Edison comes out to certify the system. The only thing that they really do is they really want to see, number one, whether or not your photocells drop when the grid's dropped. In other words, they stop generating power. And number two, when the grid comes back online, how long it takes for the photocells to engage. My guess is that's really why they want that. It's police, the fire department, and all this other stuff. I just don't buy it, my opinion. So there's a bunch of software that we've also used and we also utilized. Enphase has this software called Enlightened. And Enlightened provides you, it comes with the inverters. It's basically free. There's a central database that they maintain, all the information about your photocells. It does things that I think that you would normally expect. It looks at the amount of power that's physically generated. It keeps track of the energy that is being developed, but also it looks all the way down to the individual panels. And that was one of the reasons why we went with Enphase and this distributed microinverters, because I can look at every panel and I know just about as much as you'd want to know about how that was operating. I know what power it's generating right now. I know how much it generated today, yesterday, and the week before, and it's totally just separate. If a shadow goes across these panels, you can actually see the shadow of a tree move across the panels as the power goes up and it goes down. Sampled about, I think it's every 15 minutes. It provides a sample, updates the database, etc. Okay. Another piece of software that I got just before we implemented this was the DTE Insight. Again, I don't know what people have seen, if they've seen this, but it really is a handy tool. If you're doing solar, you have a solar system installed, or you're thinking of installing one. It certainly is very enlightening. It helped me a tremendous amount in identifying some of these vampire power loads that seem to happen overnight. But it also helped me understand what kind of loads I'd be dealing with during the day. This is particularly important if you're going to add some standalone capability and some battery functions. For example, one of the things that I discovered is we installed this wonderful oven for my wife in our last kitchen renewal. And one of the features of this oven was the fact that it was a convection oven, a very high-end oven, but it took almost no time for it to heat up. Well, when I got this insight, I said, now I know why. Because it was putting out these pulses that were using, 8 kilowatts. It was pulling about 40 amps through that line. And, being able to deal with that with a solar battery on top of everything else would be challenging and will be challenging. But one of the things it does too is it gives you an idea. This is a reading off of the meter, by the way. It's not off of those main lines coming in from the meter. This is actually coming from the meter. So it gives you an idea what DTE or what the utility is seeing in terms of its consumption or the power that's being generated back into the grid. One of the things, though, that they only allow you to do this, by the way, on the 1 meter that is a solar meter. They wouldn't allow me to hook to the hot water meter or the geothermal meter. And the geothermal meter was obviously, if we want to do standalone and we want to be able to, during grid outage, be able to be self-sustaining, we wanted to be able to run our geothermal at some point in the future. This didn't give me an idea of what was happening to the geothermal. I found a really nice software system, though, in this company called Emporia. I don't know whether I would recommend this to anybody, by the way. This thing is really sweet. It is like $100, and it comes with like the 2 main probes for the main buses, and then 8 additional probes for each circuits for $100. That's really kind of phenomenal. But I put that on my geo system so that I could see what I was going to be dealing with if I tried to roll this into a future phase. And what happened is what I kind of expected to happen. And if you take a look at this, this is my this little bit down here is my fan that runs pretty much all the time, and is kind of an air handler. This is my compressor starting up, and immediately what happens is you see this huge spike on the startup load, and that's the lock rotor amperage that happens when something starts up, particularly when it starts up under load. Even though the current that the compressor is pulling is only about 2.5 or 2.25 amps, the startup load is almost 7 amps. And then this is I have an open system, geothermal system. So my pump kicks on periodically in order to maintain the water source. And then this is the pump kicking on, and you can see there's another startup load that's associated with the pump that's much lower. These startup loads can be a challenge, and particularly for a system that isn't designed, a battery system that isn't designed to be able to handle it. Enphase has got this in charge that what they do is they say that they spread out this startup load for a longer period of time and bring the application down. When I bought the geothermal, they said if you're ever going to do solar, you're going to want to buy this other system and not this one. And oh, by the way, it costs like $1,000 or $1,500 more. And the thing that they do is I think they put a significant capacitor at the front end of here to be able to load that capacitor, and then they start the motor for the compressor from that capacitor. There's actually third-party systems that you can buy that will bring this down, but it's still something that has to be done if you ever want to put your geothermal in as a part of your solar system. It would be nice to have a kind of a discussion at some point. Maybe people have successfully done this and they successfully addressed this issue. So here's some numbers. Production was about 6.3 megawatt hours over about the last 12 months. Not quite 12 months. I actually went into production with DTE in the middle of November. So we're a couple weeks off, but we generated 6.3 kilowatt hours off of that 4.13 kilowatt rated system. The estimate that the company gave me was 5.1 megawatt hours. Now you might look at this, you might say, oh my goodness, that's really a good deal. That you actually exceeded your actual production by that amount of megawatt hours. And the reason for that is if you recall, if you look at the rating of the system based upon the inverters were all 295 watts apiece. 14 of them gave me the 4.13 kilowatts. But if you look at the actual photocells, the photocells were actually rated at 390 watts apiece. What that means is on a very clear day and on a very cool day, you have clipping that occurs at the top of that. And let me go back here to this one. If you'll notice up here at the top, as the power generation goes up, the top of this ends up getting clipped off. And the reason why it's getting clipped off is because the photocells are producing more power than the inverters can physically handle. I was kind of disappointed in that because if you follow this up, it goes up a little bit further and this area under the curve is lost. What I've been told, and what the company convinced me of is that is true that you lose this, But by oversizing your photocells over your microinverters, you gain power all the way down the curve. So what would normally happen is this would come up at a shallower angle and then peak here and then come down. And all of that area that was under the curve is all power, additional power that you gained with your set of inverters. I'm not sure I was clear in explaining that, but that is basically the reason why, even though they estimated 5.1 megawatt hour generation on a 4.13 kilowatt system, I actually generated 6.3. Actually, I think if you do the modifications, you look at the clipping, it's about 6.4, which is right in the number. So the total, So the total cost of this after taxes, after I got the 30% taxes, was about $8,000 bucks. The price of the equipment and the consulting all bundled together was about $7,400, and then there was about another, I think, $800 of miscellaneous stuff that I ended up buying: conduit, wiring, junction boxes. I bought some tools that I rolled into the project as well. So the 12-month savings on the energy bill was between $820 and $850 bucks. It's hard for me to know exactly, because when Detroit Edison put me into production in mid-November, I expected that to show up on the next bill, and it didn't. And actually they said that, well, you're not going to get the next bill. We're just going to delay that for a month. It actually ended up being delayed until May before they actually figured it out. They rolled everything in together, and I couldn't really separate everything out. But the savings is approximately $820 to $850 over the last 12 months, which gives me about a 10-year payback, which makes it okay. And to do a kind of a apples and apples comparison, the energy consumption, July 2019 versus July 2020, the total house energy consumption was reduced by 56.9%. That included my geothermal, my hot water, and the house. Now the house had a significant excess. It had about a 30% excess, which it gets sold back to DTE at their 7.6 cents per kilowatt hour. The reduction in my bill, though, even though the total power I used was 56.9% reduction, the reduction in my bill was really 41.4%. And the difference between those two, a little bit of it was a rate difference. There was a 5% rate change. But a lot of it was just the fact that they were selling me power at somewhere between 15 and 22 cents a kilowatt hour, and they were buying power from me at 7.6 cents per kilowatt hour, which meant that there was a penalty of around 22% based upon this Rider 18 versus what I call this monthly method of reconciling, because back in the summer of 2019, they told me they were going to bill one way. They were going to bill on a monthly basis, look at your total consumption in the month, and then total generation, subtract the two, and they're going to pay you 7.6% for the difference between the two. And of course, that's not how it ended up working. It ended up not being on a monthly basis, but a moment-by-moment basis, which is very much to their benefit. And like I said, if you run the numbers, it's about a 22% penalty, not even looking at the net metering. So issues that I've yet to work through is this geothermal heat pump with the solar install, because that's part of my next phase. I want to be able to roll that in. And then there's an error that DTE is making in these Rider 18 billings. And I can't seem to get anybody's attention on it, because let me see if I can really quickly describe this. This is an example. This is a schematic, if you will, of what the power generation looks like. There's 3 meters. There's the geometer, which is time of day. There's the house meter, which is Rider 18. And then there's a hot water that's interruptible. And then the DTE's grid ends at the drop, which ends out at the top of the house. The thing is that there's a knuckle, there's a joining between where their grid ends, between Detroit ownership ends, and the meter. So what happens is when I am generating excess power at my meter, the theory is it goes back into the grid and they give me 7.6 cents per kilowatt hour. The reality is, though, is a lot of the time, because remember, I'm generating excess energy at the hottest part of the day when a lot of cooling is happening. The reality is, though, a lot of this time and a lot of this energy is going from my meter directly over into my geometer and then being used for my geothermal cooling. Basically, what they're doing here is they're buying my power that I'm generating at 7.6 cents per kilowatt hour. They're selling it to me at 21.5 cents per kilowatt hour, and it never leaves my property. It never hits their grid. And I keep telling them they need to be looking at, if they're going to do moment by moment, they need to look at both of these meters, actually all three of these meters, so that only what goes on back onto their grid do they give me the 7.6 per kilowatt hours. But as I mentioned, I haven't gotten anything from them. So anyway, I'm hoping that we can have a discussion along those two issues, if you will. That's all I got, John. You're muted.
John, David Arnosti here. Nice seminar. Thanks very much. Question, can you give us some details on your geothermal system?
Yeah,
is
so
a deep, are these coils, or is it a deep well, etc.?
Sure. So my geothermal system is an open system. So I have a well that I had dug specifically for the geothermal. So I've got a 1 horsepower submersible pump that will support about 22 gallons per minute. So it's really a high volume pump. I don't know whether you noticed or not in my original slide, but we sit between two marshes and a lot of power. Hang on just a minute. So we have a pretty good supply of water. I have a 2.5 ton system that was installed about 10 years ago. And we have been just extraordinarily happy with it. It's a relatively older system, 10, 12 years ago. Its payback was in like 5 or 6 years. And we use it for whole house cooling, whole house heating. I do not use the heating coil. I turned off the heating coil. I turn it on every fall to burn off the dust, but I don't use the heating coil at all through the year. I do cycle it a little bit, but that's it. It's all the geothermal. Now, back about 8 years or 9 years ago, there was a real incentive on insulating your house. I put a lot of insulation in the house. I put all new windows in the house, all new doors in the house. I have 4 inches of blown insulation, which is what was in there originally with the house, but I put an additional 8 inches of fiberglass insulation on top of that. So the house isn't real tight, but it's very well insulated.
Thank you.
Hey, John, maybe you should stop the screen sharing, then you'd be able to see everybody.
Oh, I'm sorry. I'm sorry.
That's okay.
Yeah.
That was a very interesting presentation.
The interesting thing is that I got to tell you, Detroit Edison really did not know what they were or how to deal with this. They really did provide information in the summer, right after Rider 18 became effective. that was not consistent with what they actually did. Furthermore, I keep trying to explain to them that what they keep saying is wrong. It's one thing to say, no, we're going to do it at the meter and that's what you get and that's it. Don't say that. They say on our grid, on our lines. And I keep saying, but that's not what you're charging me for. That's not what you're doing. And I've been kind of disappointed by that disconnect in that I've never been able to get somebody
Yeah,
that I
John,
can talk
that's
to.
interesting. I didn't realize that the situation you described could even exist, but it kind of makes sense that, you know, what's happening with your solar and geothermal, and that DTE is just kind of ignoring the reality of it. They don't want to know about the reality, probably. They probably understand it and just don't want to acknowledge it.
Yeah, I'm not sure, because it's a complicated, I thought they were going to do the monthly, and I could see how they could do the monthly fairly straightforward. The moment by moment, I kept asking them, how are you going to do this? I don't think you have the technology. Oh yeah, our meters are smart. I kept, you know, I haven't seen it. You know, even with your Insight, you can only do that on one meter. You can't do it on all 3 meters. So I don't know. It is what it is.
This is John Freeman, and I just want to say that the example you gave is probably the best example of the scam that these utilities pull, where, you know, they take the electricity, the exported electricity that we export back to the grid, and turn right around and sell it to our neighbors at the retail price. But in your case, as you said, you're taking the electricity you're exporting and turning right around and selling it back to you, even though it doesn't even leave your house, and charging you, as you said, 20 cents per kilowatt hour. You know, so, I mean, that is the ultimate kind of ironic twist and the absurdity of the policy.
Yeah. And the thing is that they keep saying that it's on their grid. I mean, if they were even honest about it and say, well, you just got to live with it. But they keep explaining it wrong up and down their organization. So I don't know whether there's any, I don't know what you can do.
Well, I'm going to file it away and use it as an example in some of the regulatory proceedings and the legislative activity.
John, I've got a paper that I put together that explains this in detail. Can I send it to you?
Love it. Yep.
Okay, I'll send it on to you.
Thank you.
If anybody has a question, just unmute yourself. Go ahead, Jan.
John, if you didn't get the special rates on your interruptible hot water and your geothermal and just had them on the same circuit as the rest of the, the same panel as or same meter as the house, then you would be able to use your own electricity, right?
That's correct.
But then you wouldn't get whatever advantage. So you'd have to do a calculation about those various rates and how much they're charging you. Don't they charge you some monthly fee for having extra meters too?
So they charge you $2 a month for the 2 extra meters.
Okay.
So $2 for the interruptible power, $2 for the geothermal, but they charge you $7.50 for your main meter.
Oh, not if once you're a senior, they only charge you $375.
Well, I am senior, and they charge me $7.50.
Oh, you have to tell them you're a senior.
Okay.
Call them and tell them you're a senior. I don't know I think it's only like 55 or something.
Do you have a Rider 18 program on your meter though?
I'm not sure what it's called. Right now I just have regular net metering, but it'll expire next year because my system was installed in 2011.
Well, you should pay attention, because the Rider 18 is what they designate my meter as. And when I asked them about, hey, because I thought I had a senior rate when I went into this, and they said, no, all that's gone. You're going to be a Rider 18 meter, and here's the rates. And the rates look basically the same, very close. What I didn't realize though is that charge went up and some other things changed as well. Here's the thing though, is the rates can be hugely different. The irony of this whole thing is that it's not in Detroit Edison's interest to do what you just said. Because if you do what you just said, I give up my time of day rate. I have no rationale, no reason to lower my thermostat through the day or to conserve energy on those on-peak times, which is exactly what they don't. It's really contrary to their interest to force me to doing that. So, I mean, that is one option is to collapse everything. For example, I am going to give up my interruptible hot water heater because I've got some other problems too. That's an old line. It got chewed for a variety of, that's another whole story, but I have to replace that. And rather than replacing it, I'm just going to tie it into an existing service. There's only about 1/10 of a cent, not even 1/10 of a cent, 100th of a cent difference in rates. The geothermal is really different though. It's hugely different. There's like a 2 or 3x difference in those rates. It's very substantial. So, but there's other things that I can do. I have got a transfer switch that I can play games with if I have to. But I don't think Detroit Edison wants that. And I'd rather they fix this rather than forcing me to play games with how I manage power internally. The next phase of this though is when I can break that connection either in all or in time of day or under certain circumstances. It'll give me more flexibility to do this. The world is changing for Detroit Edison, and they don't seem to want to go down the path. And a lot of things they're doing, it's just not in their interest. And I guess that's part of my frustration is when they do something, it's like interruptible power. It's really neat to be able to have power that you can say, well, this guy, I'm getting close to my maximum load. I'll just cut these guys off. They're happy with it. They got a little bit of benefit. That's very much in their advantage. But because they do these other stupid things, they're going to lose that advantage. And it's not, so anyway.
Hey, John, do you know, has your hot water been interrupted on that interruptible rate or don't you know one way or the other?
No, it's on the interruptible rate.
Yeah, but has it actually been interrupted?
It does interrupt occasionally, but we installed a fairly large tank
Okay.
Originally to compensate for that. And quite frankly, we never really noticed it. We do notice it sometimes when there's a lot of guests, a lot of people that, when it gets interrupted and they use all the hot water, it's a few hours before there is. But it's not during the time we typically do things anyway with the hot water. So.
Other folks have questions, just unmute yourself to ask.
Yes, I have one. This is Dana Drixna.
Hello.
I'm wondering, John, do you have the hot water assist on your geothermal system, or is your hot water completely separate?
I couldn't cost justify it.
Okay.
I try to do things on a 10-year payback, and with the additional cost, I'm only spending $20 a month on hot water. So, if you add another $1,200 to a system, it takes a long time, to pay it back, and it just wasn't cost justifiable. So I did not do it.
Hey, John, just to clarify your 10-year payback for your solar system, that really didn't take into account your labor, right? Because your labor was free, right?
My labor was free.
Yeah, because I was just thinking that's a very low payback for solar, but of course your labor was free, and it's a good thing you've got some son and son-in-law to help with those panels, lifting them up on the roof.
Well, other than the 4-year degrees I paid for, so.
Well, that's true. Good point.
John, this is John Freeman again. I have 2 questions. Where is GoGo Solar? Where are they located out of?
They're located out of Southern California.
Okay.
And I had a lot of pain going to Southern California to do this because I looked locally to see if somebody was doing the same kind of thing. I realized that I didn't want to deal with all of the, gee, how do I buy this? And, how do I get the best deal? And how do I get all the pieces? And how do I put up the rails and all that other stuff? And I really wanted someone that I could talk to, consult with if I had a problem and an issue. I wanted somebody local, but I just couldn't ever find anybody local to do that. They wanted to do everything, give them a bunch of money and they would do it, or you figure out how to do it yourself. These guys have done a ton of installs in Southern California, and they were very experienced with doing that. They gave me hints on how to deal with the electrical inspector. They gave me hints on a lot of things that really worked out well. Had a couple of issues, called them up, they were on the phone. I mean, they picked up, the phone got transferred to the guy who had done a bunch of installs, and he walked me through issues. So I'm tickled pink with the help they gave me. I went in very skeptical also. I was concerned that I was going to have issues. But I had no problems with parts. All the parts were there. As a matter of fact, they sent extra parts to make sure that if we broke something or lost something, it would be there. I don't know. I don't think I could ask for more. By the way, our electrical inspector, I was expecting to have some issues, and he was just great. He gave me all kinds of hints. It took 2 times for me to finally get through. The first time he had a bunch of issues, but then he signed them off the second time. But he told me exactly what I needed to do and what the issues were. He was a great guy. He was a lot of help.
What jurisdiction do you live in?
Chelsea. He's in the Chelsea building.
Yeah, my second question is, have you talked to your local realtor at all to see whether all of this adds to your property value? So that if we ever down the road want to sell your home, will you be able to recoup your investment?
No, not an issue for us. I plan on dying here.
Okay.
Well, any more questions before we kind of adjourn? Any other comments or questions? Okay, well, thank you very much, John. This has been very informative. You know, it's interesting to see all the issues that come up when you kind of do these kind of high efficiency renewable energy systems in parallel with each other. You know, obviously there's some challenges with it, and the utilities aren't very well set up to kind of make it easy for you.
If anybody wants to, if you know of anybody else who wants to talk about integrating their geothermal into these PV systems, I'd really like to converse with them.
Okay.
Because that's my next phase, is to be able to do that. I know I need a battery integrated in here. By the way, one of the things that may not have been obvious is that since I did this in the barn and I put the combiner in the barn, that means the battery's got to go in the barn. So it's got to go into an unheated environment in Michigan. And I did that knowing that a little bit about what they were doing with the batteries. For example, the Tesla wall has an internal heater that maintains internal temperatures and internal functionality, but it only goes down to like 10 degrees or minus 10 degrees, I think. I read something that Generac has a system that will do something similar, but there's a lot of things that's going to be necessary in order to do that. I'd love to talk to people.
Okay, well, hey, we'll keep that in mind.
John,
Pardon me?
this is John Freeman again. One more question. Did you hire an electrical contractor to help you wire all this stuff?
No, I did. I'm an engineer too, and I've had quite a bit of experience wiring everything. There was a big job to bring the power out, the wiring out from the main breaker out to the barn. It was a really simple task, though, to wire those PV cells up to the combiner box. I mean, it was really very straightforward. I think almost anybody that had some level of comfort with doing electrical work could have done it. The other stuff was more complicated. Putting the shut-off switch, getting into the main breaker for the consumption wiring, that was a little more involved. But I've done a lot of barns. I've done a number of houses. I feel comfortable with it.
If I had come across a person that's interested in doing installing their own system, Could I connect them to you if they have questions?
Absolutely, absolutely. I would be glad to talk to them and get them going.
I think
Once you-
maybe John Sarver, we ought to get John and Dave Strensky to do a solar stories together, because those are the only two people I know that have done their own installations.
Mhm.
Yeah.
Yep. Good idea. Yeah. Well, again, thanks, John. Really appreciate your presentation. I certainly learned a lot. Hey, thanks.
Got a question if we got time.
Sure,
Actually,
go ahead.
too, on the inspector related stuff, are you a PE? How do you get around some of their wanting a quote professional to do the electrician work?
I actually do have a professional engineering.
Okay, so then you're legit to do it.
Yeah.
Yeah. Okay, and also on your heat pump, don't rule out us air-based heat pump people.
That's true. That's very
See,
true.
I've got an air-based heat pump with propane backup.
Yeah, very true.
So it's sort of the same thing, but not quite as efficient.
Yeah, but same issues with that startup load.
Exactly.
On a normal motor, the startup load's about, it's about 40, 50%. On a heat pump where you're starting up under load, it can be 300%. It can be a huge load that you have to handle. But there's ways to do that. I've done a bunch of research, but I'd love to talk to other people about the topic.
Because I'm looking into soft start not only for the heat pump, but for the well pump. You know, we're out in the country with flaky power. So I'm on a generator, a small inverter generator, more than I want to be. And they struggle to start the systems. I don't care much about having to cool in the summer, but I really care about having to heat in the winter. Luckily, I can force it to propane.
Send me an email and I've got some information on that we can talk about.
Okay, I don't have it. Is it available somewhere?
It's my first name, last name, John Dohner at gmail.com.
All right, will do.
Yeah, send me an email and I'll be glad to send along some stuff to you because I'm working that issue right now.
Great, very interested.
Super. Well, again, thanks, John, and everybody who attended. Thanks for attending, and come back next week. Take care, everybody.
Thank you, John.